So which? Not on the sides. Oh. Yeah, I went full screen. Yeah. I don't know. Hang on, wait a minute. This goes to this. All right, well, thank you, ladies and gentlemen. My name is Dave Valentine. As you can tell from the extremely thick accent, I'm not from around here. I'm from Canada. And I'm joined today with William,
also known as S-Tech.
And we're doing a co-presentation on 4 kilobyte intro development, which is actually kind of a unique thing because I have done presentations before on 4 kilobyte intro development. And this is a nice way for us to have two different views on the same subject. It is a technical talk, but I'm hoping that I can put it in some non-technical terms for you, for anyone that has it. Also, we have a fairly small group here. I have demo sceners in the group, and I'm hoping there's some that are demo sceners that don't know they're demo sceners yet, as Jason would say, right? So with that, let's get it a little bit interactive, ask some questions or what have you, and we'll try to address them throughout the talk.
Very good.
Okay. So first of all, just a presentation overview. We're going to talk about who we are and what are 4 kilobyte intros. We're going to show two intros today. One is called In4K. The other one is Parsec. We're going to do then an evolution of size reduction techniques so that if you're contemplating creating 4 kilobyte intros, that you can see how there's been a sort of a chain of techniques that have been used to reduce size, and it's evolving over time. And then we're going to show the end result of a 4 kilobyte framework which we put together and to demonstrate sort of just what goes into creating some 4Ks. All of this will actually be put into a website, and we'll put a package on that website. So the files will be made available, and if you have any questions about those or what have you, you can always access them from that site. And again, this presentation is not meant to be exhaustive, but an overview. There's a lot of things we had to skip, and we figured we could do at least a one-day seminar on all of the 4K, not just much less an hour. So again, as I mentioned, I'm Dave Valentine. I'm the founder of the Northern Dragons, which has now entered its, just past its 6th year of existence, so it's now on to year 7. I've traveled here from Winnipeg, Canada, so for anyone who's native to Cleveland, I know snow as much as you do. So that's something I can say. Also, I was the co-founder of the In4K site, which is probably the largest web portal or wiki which is used for 4 kilobyte intro development. And the information on that wiki is actually very, very helpful. And we have a number of contributors. It's supported by a very small scene, so we haven't seen those scalability options that Jason Scott was mentioning earlier. But I will say that our Wikipedia entry about the Northern Dragons has it founded by Polaris, Loopy, and Hawk, which is wrong. I don't know, I was there. I don't remember Loopy being involved, but we're trying to correct it. So, I've also written a number of intros, including Trees, the Ethereum. I should actually say, I've collaborated with a number of Trees. I wrote all on my own, but the Ethereum Forest I wrote on my own, Levucio, Blobzilla, In4K, and so forth have been collaborations with a number of people, sometimes in remote geographies. And I do have a personal message for Sesame, somebody that I'm anticipating meeting sometime in November. So it's a thing. And okay. As I mentioned, I'm from Winnipeg, Manitoba. Anybody know where that is? No? Okay. So Winnipeg is just north of North Dakota. We have a small population in the city, about 600,000, about 650 if you round up kind of thing. However, it does have a thriving digital arts community. So we've established a local international game development chapter. There is a game studio that has recently started as an incubation project in association with the Manitoba government. And it's really out there in order to promote the game industry, to assist people in their product from idea to out the door. So as time goes on, Winnipeg and Manitoba may not be known as just the city that forced the game industry to put the T for teen ratings on the box, but also as a thriving game development community. So maybe at some point there will be somebody from Cleveland saying, "What's Cleveland about?" in Manitoba, giving a speech something like this about the game industry. And Estec.
All right, well, I'm Estec. I wrote a lot of demos. I first joined up with the Northern Dragons when I first joined the scene. I worked on the Ethereum with them. I also did 0x0f, which was a 16-byte demo. So it's just 16 bytes. It was really sucky, but I mean, hey, a waterfall of color in 16 bytes, how can you beat that? I worked on Zero with the Northern Dragons. Then I went off on my own, started a group called Trailer Park Demos along with Tom, another scener who's in Canada. And we produced I.O. and also producing one that we're going to release here. California's nice, no snow, 60 degrees all year round, but it's boring, so that's why I'm a demo scener. All right, let's go ahead and move on.
Okay. So this is from the old school demo scene FAQ, which may and should look familiar to a few of you. But basically, an intro is really a demo program which displays sound, music. It's a light show, usually in 3D. And they're much because you get this sense of awe. Back in the day when you had sort of, or if you were attending Trickster's program earlier today, you look at this machine and you have these almost drunken-like bets saying, oh, well, I can make it display 256 colors in this mode, or this or that or the other thing. And you end up pushing that machine beyond its limits. And so, it's sort of, you go to a demo party, you get this sense of awe. And it's an evolving art form that blends mathematics, programming skill, creativity into something that's beautiful to watch and listen to. And as the technology has increased, we've focused less and less by the means of doing what we do and more into what we're actually doing. And you also see that in things that, such as the 4K intro. But the real thing with the 4K is that it is a demo, okay? Music, sound, graphics, but it means that you do it in 4 kilobytes or 4,096 bytes. So the machine that, when you think about it, right? I mean, that's 4,096 characters. That's it. You could print that on a couple pages. The interpreter, the command line interpreter inside DOS is closer to 32 kilobytes, right? Windows itself, you need a CD that's 750 megabytes or 700 megabytes in size, right? If not, for the patches, you need to download an entire DVD's worth. So this is really sort of the area where somebody can go in and focus on something fairly small and still have a technical edge to it, but try to make beautiful art. And why do people make them? Well, they make them to the same reason why they make demos, to show off, show the hardware's capabilities, show their creative abilities as musicians, and to show the programmer's abilities with 3D. And the goal, as always, is to impress, especially in 4K. Now, one thing which I will mention from naive experience is that the Dragons, when I founded the Dragons, we planned to go to Assembly, which is a very large European, based in Finland, demo event. So we founded the group. We made the trek. We didn't finish our demo. We released it anyway in one of those, hey, we were here kind of moments. And the following year was probably the most critical in the history of the Northern Dragons, because at that point it's like, okay, we came, we saw, we went. We didn't get much done, but it was fun. What do we want to do now? And we decided to work on a 4K because, hey, it's only like a couple pages of code. How hard can it be, right? Well, 4Ks are extremely sophisticated, and it led into a growth of it, because at that time it was not very common to have music, and then we saw music getting added, then more and more features, and so on and so forth. And the objective of the talk is to give you a background on this type of development so you'll have some idea about how to make them, if you so desire. The first demo viewing that we're going to do is one of my selections. I guess you could call it a shameless plug. This was released at an event. It was released at the Pilgrimage event in 2005. So that means that at this point it's 2 years old. The music is quite nice, and I'm hoping that it will show up when we hit the next button. With that music, It was actually composed by someone in Finland, so this was a collaboration between Canada and the Finns in order to create. And In 4K, again, is a site dedicated to talking about the development of 4 kilobyte intros. So let's give it a shot. Okay, I'm not hearing anything. Okay, hang on. Hang on. Of course, now you don't see anything. All right, hang on a minute. Okay. Yeah, we had the brilliant idea of one of the things that happens often in 4 kilobyte intro development is because you're trying to reduce the size, you end up doing all kinds of tricks, right? And we decided to render everything to video so that we wouldn't have the projector suddenly have a heart attack when we showed one of these productions. And of course, when I do that, it means that I have to remember that video files don't always like to be played on 2 screens at once.
That was only 4,096 bytes, which is pretty impressive, right? We got particle systems, you got music, you got text. This next one I selected because I think it represents probably the state of the art. What is possible for insane geniuses, and I don't know how they're human or anything, but this is what you can do in 4,096 bytes if you really try. jerky playback ruining the vibe. If you actually run the real demo, it's actually smoother than this playback of a video, and it's smaller. So, so that's what's possible.
Yeah, it's a gargantuan difference in size. I don't know what happened with that playback. We had tested it before. So go check it out. Go to puit.net. Type in Parsec. There's 2 productions. One's 4K. You'll know which one. So with our talk here, we're going to talk about evolving reduction. And the way that we're going to do this is that we've taken a source application from NEHE, from nehe.gamedev.net, which Jeff has up there a number of OpenGL tutorials. I think he's up to like 35 now of various subjects. And we've taken a very simple one, which has a rotating cube and a rotating pyramid, a 4-sided pyramid, that as a sample. And we're going to show you a variety of techniques to bring that down as far as we know we can go. We actually had done the presentation, then I was in the airport and managed to start to fuddle with some other ideas, and we've since being here have made some other optimizations that STech will talk to as well. So if you take that and you download it and you stick it in a compiler, the output is 11K, basically. Now you're sort of sitting there saying, okay, wait a minute, Dave, we just saw a production with this huge sphere, this beautiful scene with particle effects, with what probably has pixel shaders. I don't know the internals of it, so I can only guess. And yet to display a cube and a pyramid, flat shaded with some coloring, it already takes 11K out of the box. How the heck is this possible? So we're going to show 2 overall approaches. One is to talk about some OS-based techniques, which are really more about how to represent your program and your code environment. And then we're going to look at algorithmic. So one is inside the box, right? That's more what are we doing, how are we representing this. The other one's outside the box type of approaches. And all the presentation files, as I mentioned earlier, will be made on in 4K. So what are we trying to do? Well, you're trying to make a very small program, really, an executable image. And before you can really intelligently think about that, you're going to have to find out what an executable image actually is. Now, I know that there's the ELF format for the Linux gurus in the group. I'm not a Linux guru. However, some of the things that I will show apply to Linux, so I'm going to be talking mostly about the Win32 format. The Win32 format in Windows executables is the PE format, or portable executable format. And it's similar to the COF format or the ELF format. And you can see that you have a header, stubs, another header, a section table, and then a whole bunch of sections. Now the header, the first one is the DOS header, which basically says, congratulations, you have tried running this program on this DOS program or a Windows program in DOS. And so it basically says, hey, you can't run this program. So it's a legacy thing that's in all executables by default to say, sorry, you don't have Windows. Too bad for you. And the PE header holds the standard structures for the PE loader, and then you've got the section table. And I want to stop you from thinking that, oh, okay, I've got code, I've got data, and these are different sections, because they're not. The only thing that really puts things into various sections is its attributes. Can it be read? Can it be written to? It's more of a question of what are the rights of storing that data that decides whether it's in a section or not, as well as your standard compiler options. So the sections hold a block of data. These can be anything, right? API functions, they can be imports, values, variables, and so forth. So they have a chunk of data, and there's nothing that prevents them from being in the same section. And one of the first things that you may do as someone who's interested in 4K intro development is actually merge those 2 sections together. The compiler and linker determines how many sections there are, and there's some additional information that you can follow up on. The real goal that I want you to understand is that there's a whole bunch of headers that are in every single executable. And some of these headers have no value to a 4 kilobyte production. I'm sorry, but at some point you decide, well, you know what, we can live without error checking. Oh, and that object I allocate? Well, guess what? I'm not going to deallocate it. I'm just going to have to rely on the operating system to remove my object in memory. You start doing these things not because it's improper technique to do it. Of course, it's proper technique. You should clean up the things that you do, but when you're making a 4K, you're more interested in having that next scene having buildings in it than saying, oh, guess what, I deallocated everything I allocated and didn't rely on the OS. Right? So the first approach that a lot of 4 kilobyte intro coders use is they use an out-of-the-box compression tool. And that basically takes your program and it compresses it. And to use another example, let's say that we have a living creature. And the living creature weighs X on a scale. So what this does basically is it decides to consume the living creature and store it in a lighter way. So it's like it replaces its blood with helium or something, and it basically just stores it in a compressed way. Then when you say, okay, I want my living creature back, it actually pulls it out, extracts it, runs it, just like it was the original creature. And I know that's kind of and so on, but essentially what you have is you have another exe or image, executable image, that looks just like the original image when it runs, but it extracts itself to memory or to disk and runs it. So the program runs it, and you know, the hope is that the compression algorithm and the code is smaller when stored in that form. So we decided to take the sample, which remember it's at 11K right now, and to use UPX on it, which you can download. It's a SourceForge application. It's a very popular application. It's very well tested. There's versions for almost every OS out there on the planet. And we ran it through this. And we end up with a just over 6K production, which is a nice reduction. It gives us roughly 41%, which is still a far cry when you say, hey, well, you know, we need to get that magical 4096, right? Now, there's really one major disadvantage with this. Do you remember going back here when I said this stub and some of these things are really useless, right? I don't think a 4K intro developer is going to mind if their executable, when run in a DOS box, doesn't work, right? So we want to hack it slash and burn that. So this approach creates another Windows executable with the same DOS stub, or so, you know, to say, hey, guess what, I can't run this. So we really need to find a way of representing the code such that we don't have that problem anymore. So there's actually another executable image format that's supported by the Microsoft Windows platform, and that's called .com. I don't mean .com in sort of the industry sense or the internet sense. This predates that. It's essentially a very small executable format that has no data, that has a maximum size of 64 kilobytes. And that's supported by the original DOS platform. And it can be loaded at basically hex address and so forth. So somebody said, okay, well, guess what? What I'm going to do, instead of writing a Windows executable, I'm going to write a DOS executable, and I'm going to tack on the Windows executable. And this DOS executable, what it's going to do is it's going to write to disk the Windows executable. It's going to run it, and then if it's being nice, it's going to delete it once it's finished running. So it essentially drops this executable to disk. Now you're saying, okay, well, wait a minute. You took this program. It's got, okay, I understand it's a Windows executable. It has this header, and then you're writing this other program that spits it to disk. This doesn't make sense to me. Well, the reason why you do that is because then you can compress the whole thing. And when you compress the whole thing, you've gone back and you've compressed, again with that chart, that header right there. So you can actually shrink down those strings in that code, and you end up saving on that header. It's not really elegant. It means that you have this little DOS box, pardon me, that pops up when it's run, but it does save a fair bit in the approach. There's several file droppers that you can use. For our testing, we used GEMS dropper, and we used APAC in order to compress it. So GEMS dropper, what it does is it took the Windows executable, it tacks on the DOS program as a .com file that writes it out, runs it, deletes it, and then we used APAC to compress that .com file into the smallest version possible. So you can see at this point, we've gone down to about 5K. So we're not quite there. but we're getting much closer. Now, one of the things that you'll have to remember, though, is it's merging these two things in uncompressed form as a program that's a run stub and the executable image afterwards. So, pop quiz, anyone who's really on the ball here, what does that mean about the largest uncompressible size of your production? What I mean by that is, what is the largest production that you can tack on to a stub and have it run as a COM file? Exactly. So you've got your overhead for whatever your stub is, right? And then you've got just, let's say it's, 100 bytes or so. Then you've got 64K less, right? That basically means that the largest production you could support with this and then compress is 64K because it shows up as a COM file. Very good. So writing to disk can be a problem. Some demo competitions actually don't allow you to do it. I remember I checked with, here's something that goes back. I checked with Assembly before entering in their competition to see if it was a permissible technique. We didn't use it because they said, no, don't write to disk at all. So we used UPX, and we had a very limited size that we could work with. And then that year, 5 out of the 10 productions all used file dropping. So it's a bit frustrating, and the rules have since been changed to accommodate it. Some compo rules say that you need to put it in the system's temporary directory, which means that you then need to have this overhead code which figures out where to write it to. And again, I mentioned the 64K limit as a bit of a test. So you can see that that may impact the ultimate size your production can be. So there's a very smart individual, a Hungarian individual by the name of, that goes by the demo scene by the name of M. And he realized two things. One is he realized that Windows has cabinet files, which are equivalent to, in Linux, you might think of them as gzip tars, or zip files. You can think of them as zip files, right? So there's this native inside the operating system file format that's supported with command line tools inside the operating system that you can access. Now, the real advantage of using that is that at that point, you've got an algorithm you can access without having to store the algorithm. You only need to store, hey, I need to uncompress this, and to call or make use of the algorithm. So it's built in. It uses LZX compression, which is also typically better than UPX or APAC. And the end result is there were two sort of phases to it. One was having a batch file that called the command line to extract the production from the cabinet file and then run it. So the size of your production then actually gets split into two different files. And your production size is the sum of that batch file, which is just a script file that says, I want you to extract this now, I want you to run this program, I want you to delete the file now. Or how do we get it so that it's a single batch file? And that's something that's also been done. So there's sort of two phases to it. One was to say, let's include a batch file that runs it, drops the cab file, does everything that's there, runs the executable, or later on there was a second phase that said, okay, let's find a way of combining these two together. So you can see I've got a sample script on the top right. I apologize for those that may be in the back having a little bit of trouble with it. But it basically says extract x.cab or extract 32x. 32, there should be a space there, x.cab. Now that's something which is operating system dependent. So WinNT, Win2000 called it extract32, whereas 98 called it extract. So typically you'll see scripts that actually called both, saying, all right, we're gonna first call extract. If that doesn't work, I'll call extract32. And so that basically means that you end up with a like a script that automatically has an error that already shows on the screen even before your production is running. Now, I mentioned there was a second phase of self-extracting, and this is based off Windows XP. And I won't get into the serious technical details on it, but if you're interested, I can certainly discuss it. But one of the things that happens is that when you try running a batch file in XP, essentially if it finds gobbledygook, it will seek once it finds a 0 character, it will actually seek to a certain character sequence, trying to run the rest of the batch file. So it has this error sort of coping mechanism, you could say, if it encounters a bad batch file. So the way that this typically works is that you create a batch file, you put the cab file in it, and then you put an end-of-line sequence into it, and then you put your script. So then you can actually extract your batch file. And that is very OS specific. Now, there's a very good tool by Mumak, another Finnish fellow, that is hosted on 24to4.net, the idea that you take 20 kilobytes and you shrink them down to 4 kilobytes. However, our production, which we started with, which was 11, only goes down to 4,906 bytes. Remember, our goal is to get underneath 4,096. So we're getting closer. Disadvantages. To support OS compatibility, you have to make multiple calls. And remember when I said you can do this nifty thing with the error coping mechanism of Windows XP? Well, guess what? You end up with this really ugly line right up there when that cab file runs. It's good compression, but it isn't context sensitive. So it interprets everything that you're doing the same way. And it basically sees your program not as a program with data and code and routines, but it sees it as a big stream of bytes and bits. And to really get beyond this was the de facto standard for probably the last, I don't know, about a year and a half, 2 years ago was the de facto standard. But to go beyond that is you need to get into the code generation itself. So there are tools that are replacing the linker inside executable generation. And that actually means that it can look at and understand your code and make a better type of compression, context-sensitive compression, specifically for your program. I also mentioned for any of the Linux gurus that I was going to try to talk Linux, so please forgive me if I butcher the OS. I really love it. I used to admin on AIX many, many years ago. So cab dropping for Linux, similar approach. You use gzip. The intro runs a shell script that extracts it, and I have an example here, which basically says, take the tail end, copy it out, make it executable, run it, delete it, and exit. So it's a single line, and the really nifty thing about this is that you don't end up with any of the sort of heart-stopping gobbledygook that occurs in the Windows platform. And you can read more about the cab dropping technique. So getting into the new linkers, the de facto standard in the 4 kilobyte community at this point in time is to use a tool in the Windows 32 platform called Crinkler. And that's sort of a play on words based on linker. And it was put out by the Blueberries and TBC, Mentor and Blueberry
Those guys.
Those guys, thank you. I'm falling all over my Canadian accent, thank you. And you can find out more information on Crinkler.net. I should also mention there are some alternatives that are up in the wings. There is a link here for A-Link, which is alternative linker. And it looks like if somebody was, fairly entrepreneurial about what they wanted to do, they could also find ways of using that to reduce their size. But at this point, we break the 4 kilobyte barrier. We end up down to 2,457 bytes. Now, if that was all there was to it, we wouldn't have the productions that looked as fantastic as they are. So to show you, again, we mentioned that we're going to do the out-of-the-box techniques. I haven't altered the code in any way. I haven't changed the way it runs. It's still the same executable image. I've just changed the way it's represented. Aztec is going to talk about actually changing some of the inside the box in order to drive it even further.
All right, well, that part of the talk was supposed to be 15 minutes. It's actually been 30 minutes, so I got to really rush on this next part. All right. the compressors are limited. We were able to go from 11K down to 2.5K using the crinkler tool, which is impressive, but it only leaves 1.5K for music and graphics. It's not enough space to make something impressive. So if we really want to get down and make a good production, we have to trim that fat and get our code and our data down as small as possible so we can make a nice use of the rest of the space. So value size over maintainability and correctness. Be ruthless. There's no reason to be nice and, like he said, check for errors. You know, if an error happens, let it happen. Who cares? You know, your program crashes, you get a nice dialog box. So the first thing I'm going to do to make the program smaller is remove the C standard library. Every C program you compile gets this library in by default. It has two parts. It has a DLL that has a bunch of standard functions, printf, malloc, stuff like that. It also has a part that is the startup code. So when the operating system launches your application, it doesn't launch directly into your function. Instead, it calls this other function, winMain CRT startup, which does some initialization junk, calls static constructors if you have static objects, and then it launches winMain. So the first thing we can do is simply rename winMain to winMain CRT startup. That way the linker says, oh, this is the real entry point, not the one in the standard library. Also, we can't call any standard library functions if we don't have the standard library, obviously. So in the NIHI tutorial, she calls malloc on line, no, memset on line 215. So we have to replace that with some alternative code. Some compiler features also call into the standard library. So we can't, for example, do stack checking, you know, to make sure we haven't done a buffer overflow. So some stuff like that has to go away. If we do all these things and we remove the standard library from the linker options, we end up with a 473 byte reduction. So that takes us down to 2,066 bytes. So it's a small savings, but when you consider that it's 400 bytes, it's almost 10% of the entire production right there. So it's very good. If you don't have a standard library, there's some tricks you have to do in order to code in C. You can't use library features like new and delete. Sometimes, if you have like a big structure and you set it to 0, the compiler will secretly call memset in order to do that. So you have to be very careful. Typically, the way you would handle that is by using static memory. I'll talk more about why that's good later. Also, big one is floating point integer conversion uses a routine in the standard library. So if you cast a float to an int, you have an explosion. So the way to handle that is you get a 4K math library, which contains inline versions of all the math.h functions, so you can still use those. And it also provides an F2L function, so you can do your floating point integer conversions. We include one of these in our package that goes with this speech. It'll be on the In4K site. Actually, I stole it from a guy named Chaos, and you can Google for it on the web. It's right there. The next thing I'm going to do is remove windowed mode. Now, in the NIHI tutorial, he actually has a mode where it can be run as a window or as full screen. Well, it's a demo. It runs full screen. There's no need for that, so I go ahead and remove that. It has a switch that only renders when it has focus. Well, we'll just always render because it's a demo, and no one should ever be switching away from it. Until it exits, of course. Unless it sucks. But then you can press escape. Also, he has some code that says, no, don't start the screensaver. Well, I don't think there's any 4Ks longer than 2 minutes or maybe 5 minutes at the most, so screensavers aren't a big issue. He has some elaborate keyboard code. Well, all we need to do is check for escape key, so we can kill that. OpenGL state setup, he calls a bunch of functions that are purely redundant. Get rid of those. So just by removing obvious sort of stuff, we get a 520 byte reduction. So that takes us down to 1.6K. The next one is kind of controversial. We've been mentioning this over and over again. Remove error correction. So if you try to allocate a window and Microsoft Windows returns null, I'm not going to give you a window. Normally you'd have a nice error box that says, oh, we're out of memory or something. But hey, if you try to use that null pointer, you'll just get this, your program has stopped working. A program has caused, Microsoft will report the problem and, just some stupid generic error box because your program has done a seg fault. But that's okay. The user clicks close program and figures, oh, that demo didn't work.
That dialog box, by the way, is from Vista. So if it doesn't look familiar, that's Windows 98 was the blue screen, right? So then it was replaced with some other dialog boxes in XP. Now, of course, you've got Vista. And actually, one of the other things I'll mention is that as we go on, you can see in more and more the compatibility line changes, and that's why a good 4 kilobyte intro developer will release a 64 kilobyte version of their production called compatibility version, as opposed to 4K. So they show that they can do it in 4K, and oh, if it happens to be 5 years later, then you can run the compatibility version.
The other thing, too, is cleanup code. Now, if your program can crash and not bring down the operating system, you can leak memory and not bring down the operating system, too. It makes sense, right? So just leak everything. OpenGL context, window handles, memory, anything and everything you allocate. There's no reason to free it. Let the operating system do it. It'll clean up your mess and save some space. So we have a 406-byte reduction from removing the error handling, and we're running without protection, but I mean, hey, who cares? It works. So you can see the size is getting down by just removing stuff. Now we have to get into the realm of creative use of the Win32 APIs. Now this is probably going to be weird, but it works. For example, normally you register a window class and then use that window class to build your window. Now Windows has some built-in classes for things like buttons, edit text boxes, static controls. So we just use one of those as our window class instead. That saves a function call. Normally you call show window to show your window. Well, just use the with visible flag. Window messages. Normally you'd like to loop and process messages like resize the window or whatever, but all we're using the window for is to output stuff to screen. So there's no reason to process mouse input or keyboard input. Just simply don't even include the code. Also, because we're using a compressor, a 0 byte is typically smaller than a byte that has some random number in it. So anytime we can use a 0 as a structure field or a parameter value, that's a savings of bytes. So for example, instead of when you call create window saying, I want this window to be 800 by 600, use the with maximize flag and it'll just be full screen. Another thing, some structure fields you can leave blank, like when you go to create your OpenGL context, it wants a field that has the size of the structure for error checking or whatever. That one you can leave blank and it doesn't care, so leave it blank, save some space. Another thing you can do is store your stuff in static memory. In C, there's 3 places you can put stuff. You can put it on the stack, which is sort of the default location for new variables. So if you just create a random variable, odds are it's going to go on the stack inside your function. The other place you can put it is on the heap. So if you create your data using new or malloc, it's going to go on a place called the heap. Now those 2 places aren't that good because if it's on the stack, the C compiler has to allocate it. If it's on the heap, you have to call a function to allocate it. There's another place called the static data area. This is where variables that are declared with the static keyword go. It's also variables that are global variables go. And this is great because it's actually allocated by the operating system when it loads your program. So there's absolutely no code involved. So if you can get away with it, declare all your variables with the static keyword. It makes your code smaller. Well, experiment. Some variables helps and some variables it harms. But for like big data structures, always put those in static memory. All those techniques, using the static window class and all that other stuff, gets us about 235 byte reduction. So now we're down to 1,005 bytes from the 2.5K we started off with before we started trimming the fat. You can do better. This is for the insane and the people who don't like sleeping at night. You can use assembly language. Now, the thing to realize is the compressor